All right, so let's go ahead and get started. Sorry, I just want to stop the transcript. All right, so let's go ahead and get started. As I said, once again, good evening to everyone. I hope you're all doing well. So today we are looking at the second half of Learning Unit 8, which we said we would get to this week. Remember, I said I'm breaking up the learning unit because the hypothesis testing section would be looking at two types of tests. So I'm just going to reiterate here that we look at a hypothesis test for either a mean or a proportion. And we looked at last week the hypothesis test for a mean, and we're going to now look at a hypothesis test for a proportion. So the steps are exactly the same. The first step is always to write out the hypotheses. So you have a null hypothesis, remember, and a alternate hypothesis. Then we have, so I'm just going to indicate here, your null is H0, your alternate is H1. Then the second step is to determine your region of acceptance and rejection, exactly the same as the steps in the hypothesis test for mean. So remember, the steps don't change at all. It's just the type of test in terms of, are we working with a mean or are we working with a proportion that changes. So you determine your region of acceptance and rejection in step 2. Step 3 is to calculate your test statistic. Step 4 is to compare the test statistic. So basically compare step 3 to step 2. Compare the test statistic to the region of acceptance and rejection. And step 5 is to conclude. Okay, so exactly the same steps, no difference between the two. Where the difference does come in is where, firstly, and I'm just going to change the color of the writing here so we can see where the difference comes in. With step 1, when you write out your hypotheses, and I did mention this last week, the symbols we use for a proportion are slightly different to the symbols that we use for a mean. When we work with the proportion, the symbol pi refers to the population proportion, and the letter P, the small letter P, refers to the sample proportion. So we're going to work with these symbols here. And in your null and alternate hypotheses, it will always say pi is either, remember, if it's a two-tailed test, it's equal to and not equal to. If it is an upper tail test, then it will say less than equal to and greater than. If it's a lower tail test, then it will say greater than equal to and less than. So it will always say pi, and this is the important thing that we're looking at in the null and alternate hypotheses, that instead of using the symbol mu in the null and alternate hypotheses, we are now using the symbol pi. So for the mean, it's mu and x bar for the population mean. This was what we saw last week. And the sample mean is x bar. For a proportion, we use the symbol pi in the null and alternate hypotheses, and in the formula for your test statistic, we bring in the small letter p as well. Okay, so your first change comes in here into your null and alternate. We just use different symbols, but the test is still the same. The tests are not different in any way. It's still either a two-tailed test, in which case you'll have your equal to and your not equal to sign. In the case of it being an upper tail test, it will say less than, equal to, and greater than in the alternate. And for a lower tail test, it will say greater than and equal to in the null and less than in the alternate. So this is your hypotheses, and this is the first change between the two. The second step has no difference at all in terms of your region of acceptance and rejection. You are still doing the whole, if you have a two-tailed test, you draw up the bell-shaped curve, and there's two critical limits. If it is a one-sided upper tail test, then it's one limit on the right-hand side. If it's a one-sided lower tail test, then it's one limit on the left-hand side. The good thing about this type of test is that with a proportion test, with a test of, or a hypothesis test based on proportions, you only ever will have this table that you need to learn. So you don't need to worry about this table at the bottom here. So that's a really big advantage in terms of your proportion questions coming out in your exam. If you are selecting this learning unit, you don't have to worry about the second table, which is the one where you have to read off the values of A and your degrees of freedom. You just have to worry about this one. And again, though, the downside to this is that you do have to learn this table. So you're not going to get this one that you see up here, but the good thing is that you don't have to worry about reading it off a table. With a test for a hypothesis test for proportion, you will only ever use the table that you see on the screen at the moment, which is in your textbook. It's also in your slides, but you do have to learn them. So this is a nice part about step 2 here with the test for a proportion. You just have to worry about the figures on one table, not two tables. You don't have to worry about the possibility of having to look at a value that could potentially be in the second statistical table. So then for your third step, you have calculate your test statistic. Sorry, I'm just going to remove those diagrams. So to calculate your test statistic, it's also the same formula that we saw in Learning Unit 3. Not Learning Unit 3, Learning Unit 7, where to calculate your test statistic, which is denoted by the symbol Z or the letter Z, it is calculated as P minus pi over the root of pi multiplied by 1 minus pi over n. And this is again the same formula that we had used in the previous learning unit, Learning Unit 7, but this is one that's applicable to a proportion. Remember last week when we saw the mean, the formula was x bar minus mu over the standard deviation over the root of n. So there are differences in terms of the Z value calculation, your test statistic calculation for step 3 between your mean and your proportion. And then the last two steps are exactly the same. Again, absolutely no difference between the two. So it is exactly the same as the mean one that we did last week. We just compare your test statistic to your region of acceptance and rejection so that we can determine, are we rejecting or are we accepting the null hypothesis, and then we conclude. So this is literally the only difference. The two parts that I wrote in purple here on the top right hand corner for your hypotheses, this part here, and then this here, which is your calculation of Z. And then, of course, as I said, we only work with this table. We don't need to worry about the statistical table 2 from your appendix. So let's now look at these two questions that you see up on the screen. We're going to follow the same 5 steps that we have written out here. I am going to erase it from the screen though, so we can have space to work. But again, we're working with exactly the same 5 steps and just working with a proportion. These are the symbols that you see on the right-hand side here, and then that is the formula for your test statistic. So when we're working with a mean, we said that, and this was what we did last week, we said that what would help us to identify that we're actually working with a mean is you would see the word average or the word mean used in the question. So I'm just going to take you back to that in the two questions we worked with last week. You see that in the first part of the first example, they said on average. Here, if you look at this part that I'm putting a square around, that sentence said on average. And even the example at the bottom, the first sentence says on average. So that's your key to identifying that I'm working with a mean and not a proportion. Now, with a proportion, what we're looking for is either a percentage that's being given to us, or we're looking for a so many out of so many scenario. Sorry, out of. So, for example, let's say 2 out of 10 times, or 5 out of 6 times, and so on. Or they'll say to you 20% of the time, dot, dot, dot. So, this is how we would identify that you're working with a proportion as opposed to a mean. So, before we continue with the example, I'm just going to put in a quick table here that just helps you to identify when we're working with a mean versus a proportion, what the difference is between the two. So with a mean, we said we're looking for the word average, or maybe they could potentially use the word mean itself. This would tell us that we're working with a mean. And for a proportion, they would either give you a percentage, or they would say, as we said, so many out of so many. Like I said, 2 out of every 5, dot, dot, dot. The second difference between the two is the fact that we use the symbol in your null hypothesis and your alternate hypothesis. And for the proportion, we use the symbol pi. So that's the first difference. This is the second difference. The third difference is the way in which we calculate the test statistic. So with a mean, we said it's x bar minus mu over your standard deviation over the root of n. And for a proportion, it's p minus pi over the root of pi multiplied by 1 minus pi over n. And the rest of it is pretty much identical. But what I am going to add here is that you use the table from the slides as well as table 2. So you could use either one of them for a mean, or I'm going to say table in textbook or slides. And here for a proportion, we only use the table in your textbook or your slides. We don't use the table 2 of the appendix. Okay, so that is your main difference between the two. So let's look at the examples up on the screen. I do actually see that the first example up here is also of an average. So the first one is of an average and the second one is a proportion. So let's work with these. I am just going to clear this off the screen. Don't worry if you haven't had a chance to catch that, because naturally it will be available on the recording, so you can catch it again in the recording. All right, so let's look at the first question and highlight important bits of information, write down anything that will be necessary in the calculation, and then start to work with the steps. So it says that a shop owner claims that on average, so again, the moment you see the words on average, it immediately says to you, I am working with a mean. So we know that we're working with a mean, and I'm just going to write that at the top here. It says his claim is that his shop has a daily turnover of 75,000 Rand. Now, remember, I also said to you last week that in the opening sentence, generally, they always give you the population value. So that would mean that this value of 75,000 Rand is our mu, it's our mean of your population or your population mean. So, what I'd also like to point out here is that they said that his claim is that the daily turnover is 75,000. Not more than 75,000, not less than 75,000. It's 75,000 exactly. So, again, here you need to look out for these key words because these are the things that help you to identify the type of test that you are working with. So, in this question, they did not use those additional words, which means that it is a test, a two-tailed test, because here we are looking at exactly one value. Whenever they just say one value and they don't use the words more than, less than, at least, at most, greater than, and so on, as long as none of those words are included, it indicates to you that it is a two-tailed test. So immediately from that, we know that it's two-tailed. Then it says test this claim at the 5% significance level. So you have your significance level here. So I'm just going to write down then that your significance level is 0.05. Remember, the letter A denotes your level of significance. So test this claim at the 5% significance level. If the average daily turnover for a sample of 88 days was 71,500. So this tells you, firstly, you know your sample size, which is 88. So n is equal to 88. And then it says that the sample average, it said the average daily turnover for the sample was 71,500. So the 71,500 then is your sample mean, which is denoted by the symbol X bar. So this then is everything that we need. And then sorry, I didn't read the last sentence. It said assume a population standard deviation of 4,450. So your standard deviation then is 4,450. Now, there's two things I want to point out from the last two sentences that we just read. The first thing I want to point out is that the sample size is 88, which means that we have a sample size that is greater than 40. Now, remember the rule I said to you in terms of your tables, those two tables that we had used, and I'm going to scroll down to them. We said that this table would be used only when you have a sample size that is greater than 40. And this table would be used when you have a sample size that is less than or inclusive of 40. So in this case, it is definitely not applicable here. It's not a sample size that is less than 40. So that means we are not using this table. We're going to then use this table because this is now a sample size that is greater than 40 because our n value is 88, which is obviously then greater than 40. So this means we are using a figure from this table. So that's the first thing that would have pointed out to us that we're using this table as opposed to the second one. The other thing that would have pointed out to us that we're working with that table is the fact that they said to you there is a population standard deviation. Whenever you see that a question in applicable to this hypothesis testing says to you that there is a population standard deviation, then immediately you know again that you are working with the second table. So there's two things that told us we're working with this table and you need to use a figure from here. It's the fact that the sample size was greater than 40 and the fact that they said to us there is a population standard deviation. Okay, so those are the two things that I just wanted to mention to you that would play a role in identifying which table we're working with, which would then obviously affect our critical limit. So now that we have all of our necessary information, we can start the process of your 5 steps, which always starts with writing out your null and alternate hypotheses. So remember, we're working with a mean, so it needs to say mu in the null and alternate hypotheses. We know that it's a two-tailed test, which means it must say equal to and not equal to in the null and alternate hypotheses, respectively. And then you literally use the value for mu, which is 75,000 Rand. So it's going to be equal to 75,000 in your null and not equal to 75,000 in your alternate. And like that, you are done with step 1. So I'm just writing here that it is a two-tailed test. So we're done with step 1. Step 2 is now to determine your region of acceptance and rejection. So remember, I said to you that it's not necessary to draw up this diagram, but it really does help in terms of being able to visualize your region of acceptance and rejection and where your test statistic will fall. So now, once you have that drawn up, and remember, this is your bell-shaped curve for your two-tailed test. It's where you draw up the bell-shaped curve, and because it's two-tailed, there's two critical limits on either side, on the left and on the right. Now, how do we get to those critical limits? Meaning, how do we determine what value these two lines hold? We know that the one on the right will be a positive figure, and we know that the one on the left will be a negative figure, because whenever you have a two-tailed test, the one on the right is your positive one and the one on the left is your negative. So how do we get to that value? So all we need is, we know that we're working with this table, and what we need is, we need to know what is the level of significance and what is, so I'm going to write it here, your level of significance, and we need to know what type of test it is. So we know that it's a two-tailed test. We wrote that already on the screen. And we then also know what your level of significance is, which was here at the top, 0.05. So all we're doing then is taking that to our table. Sorry, I just want to remove that. So we're taking that to our table, and we know that A is 0.05, and we know that it is a two-tailed test. So the two-tailed section of the table is the dark gray shaded area, and 5% is here. It is the second one in the table. So if you go to in line with 5% and your two-tailed, your critical limits are 0.0. Oh, sorry, your critical limits are a positive and a negative 1.96. Sorry, I was reading out the significance level. So at a 0.05% significance level, it's a positive 1.96 and a negative 1.96. So that means when we go to our diagram here, we're going to put in the positive 1.96 on the right and the negative 1.96 on the left. And like that, we now have our diagram for our region of acceptance and rejection. However, we do need to write this out in words, because the mark allocation is for the words or the statements in terms of your region of acceptance and your region of rejection. So how do we write that out in words? To write it out in words, you will first say that you will accept the null hypothesis if the test statistic, your Z statistic, you can literally write this out in words. So you can say it lies between, I would suggest those. So I'm actually not even going to do that. I'm going to show you how to write it out with symbols. So remember, I said to you last week, in fact, you don't even need to write the word Z stat there. just show the Z here. I said write down the Z, and on the left hand side show the less than equal to, and on the right hand side of it put in the less than equal to. And on the right hand side write down the positive value of your critical limit, and on the left hand side write down the negative value of it. So what this is basically saying to you is that you are covering this region within the acceptance portion on the diagram, which is saying to you that you should accept the null hypothesis if you find that when you calculate the test statistic, it is equal to or lies within those values of a positive 1.96 and a negative 1.96. So this is your region of acceptance, and then your region of rejection. So you'll say reject the null hypothesis if your Z value is either on the right hand side, if it's greater than a positive 1.96, or on the left hand side, if it's further negative. Sorry, I forgot the sign. If it's less than a negative 1.96. And that is your region of acceptance and rejection. Now that you're done with your regions of acceptance and rejection, we can now calculate in step 3 your Z statistic. So remember the symbols or the formula is P minus pi over the root of pi multiplied by 1 minus, oh sorry, I'm using the wrong formula. This is the proportion one. For the mean, it is just x bar minus mu over the standard deviation over the root of n. So your x bar figure is at the top here, 71,500 minus your mu value is the 75,000 over the standard deviation is the 4,450 over the root of n, which is 88. So when you calculate this value, it gives you minus 7.38 to 2 decimals as your test statistic. Now the fourth step is to take that minus 7.38 and look at the diagram and look at where it falls on the diagram. So immediately the minus 7.38 is definitely on the left hand side here. It's going to be further to the left. It's basically further negative, further into negative values. So it will be on the left of the minus 1.96. And this is our region of rejection. So this then says to us to conclude that we will reject the null hypothesis, but we can't just leave it like that. We need to further substantiate why we are rejecting the null hypothesis. So you will say we will reject the null hypothesis, which indicates that. And now we go back to the null hypothesis. And go back to your null and your alternate, because obviously those are together. If we're saying we reject the null, that means that we are saying that the null hypothesis is not true, which means automatically then that the alternate hypothesis is true. And the alternate hypothesis is saying that the average turnover is not 75,000 Rand. Now, remember at the beginning, they said that the shop owner claims that his daily turnover is 75,000 Rand. So basically, his claim was here in the first hypothesis, in the null hypothesis. But what we're saying now is that that claim is not true, that his turnover is not 75,000 Rand. So you can either say, which indicates that the CEO's claim is not true, or if you want to, you can elaborate and you can also say that this indicates, and I'm just going to put in a slash here to show you what you could also say. It indicates that the shop does not have a daily turnover of 75,000 Rand. So the shop does not have a daily turnover of 75,000 Rand, which is what the shop owner was claiming. And that is it for the first question. So you did the 5-step process, you wrote out the null and alternate hypotheses, you know what type of test it is, you know where the claim is lying in the null hypothesis. You then determined your region of acceptance and rejection. You used the table that we saw here to get to your critical limit. We wrote it out in words. We then calculated your test statistic. We compared that test statistic on the diagram. We saw that it's in the region of rejection. So when we concluded, we said that we'd reject the null hypothesis, which means we are rejecting the claim that that shop owner was making. It is false, or it's not true, or you could say that the shop owner does, sorry, that the shop does not have a daily turnover of 75,000. Basically meaning it's either less than or it's greater than 75,000, but it's not 75,000 itself. All right, so that is question 1. Let's now have a look at question 2. So I'm just going to remove this here. So question 2 says to you that a large manufacturing company claims that 10% of its customers make a complaint about the company's products. And again, here, immediately, the moment you saw that percentage, it immediately said to us, we are working with a proportion. So immediately here, I'm going to write down on the side that it's a proportion that we're working with. And also, we saw a percentage, which means that we definitely are also working with a with a proportion. So here, the claim is that it's less than 10%. So two things are going to come off that first sentence. Firstly, in fact, three things. So firstly, we know we're working with a proportion. Secondly, in the opening sentence, you are generally always given the population value, and the population value here is denoted by the symbol pi. So as a decimal, pi is then 0.10, which is 10% as a decimal. Then the third thing that we were able to get from this opening sentence is that they said the claim is that it's less than 10% of customers that make a complaint about the company's products. So the word less than has been included in the sentence. And when we say less than, remember we're literally saying less than 10% or less than 0.1. I'm just going to leave it as a decimal because we work with it as a decimal in the questions as well. But if you want to, you can also just write it as a percentage. Just make sure that you remember in the calculations, you would need to convert it to a decimal. So we're saying less than 0.1, and this is the claim that's being made. Now, I want to read the rest of it, but I also just want to point out to you while we're on this, just to make it easier before we read more information and get more confused, let's write out the null and alternate hypotheses, which is step 1. So remember, for a test of proportion, it will always say pi in your null and alternate hypotheses. Now here, we need to write this down in the hypotheses. The less than 0.1, which is the claim that's being made. Now we need to know, where does it go? Is it going to go into the null hypothesis, or is it going to go into the alternate hypothesis? And remember last week I said to you that with your null hypothesis, the most important characteristic of the null hypothesis is that it must have the equality sign. Whether it's literally the equal to sign, or whether it's greater than equal to, or whether it's less than or equal to, as long as the equality sign is there, then it goes into the null hypothesis. Now, if you look at this less than 0.1 that I wrote at the top here, this does not have the equality sign. So this cannot go into the null hypothesis, meaning it has to go into the alternate. So that's less than 0.1 in the alternate. And then automatically the null and alternate always say the opposite of each other. So the null will say greater than and equal to the 0.10. And like that, you are done with your hypotheses. You have your null hypothesis, your alternate hypothesis, and the only thing we need to do, in fact, two things we need to do, is firstly, let's just indicate where the claim lies. So, is the claim in the null hypothesis or is the claim in the alternate hypothesis? So, his claim was that it's less than 10%. So, the claim that the company is making, sorry, I said his, I meant the company. So, the company's claim is in the alternate hypothesis. And the second thing we then need to look at is what type of test we're working with. Now, I said to you also last week, whenever you need to know the type of test that you're working with, just look at the sign in the alternate hypothesis. If the sign in the alternate hypothesis is the less than sign, which is the case in this example, it's a lower tail test. If there is a greater than sign in the alternate hypothesis, then it is an upper tailed test, a one sided upper tailed test. In this example that we're working with, it is the less than sign in the alternate hypothesis, which means that it is a lower tailed test. So we know that it's a lower tail test now. Let's write that down here somewhere so that it makes it easier when we get to the next step. So you have your lower tail test now. Now let's read the rest of the sentence because now we've written out our null and alternate. We know where the claim lies. We know what type of test we're working with. So the next part of the sentence says, or the paragraph says, test this claim at the 10% significance level. So A is equal to 10%, 0.10 as a decimal. And then it says to you, if the survey found that 29 out of a random sample of 320 of the company's customers did make a complaint about the company's product. Now, this 29 out of the 320. So 29 out of 320. What is it? This is the letter P in the formula, which we need to convert to a decimal because we work with it as decimals in our calculations. So as a decimal to two decimal places, this is 0.09. Now you do need to show the working out of that exactly like I'm doing here on the right hand side because there are marks allocated to it. So this is your value of P. And they also told you here that the sample size is 320. They said out of the sample of 320. So I'm going to say here that n is equal to 320. So basically we have A, we have pi, we have N, we have P, and that's actually all we need for our calculations. So let's go ahead and now continue to the next step, which is your region of acceptance and rejection. So we wrote out your null and alternate hypotheses. Your null will say that the pi value, your population value, is greater than equal to 0.1. Your alternate will say that pi is less than 0.1. And this is where the claim is being made. Then it's a one-sided lower tail test. We know that as well. Now we can draw up your bell-shaped curve. Because it's a lower tail test, there is one critical limit on the left. Everything greater than and equal to it is your region of acceptance. Everything less than that value is your region of rejection. Now, how do we get to that value? So again, here we need two things. We need the level of significance, which we know is 0.10 as a decimal. They told us that here it's a 10% level of significance, and we also wrote it at the top. The other thing that we need is the type of test. So we know that it is a lower tailed test. And then we're simply going to go to this table. Remember, this table is always going to be used for a proportion. You are never going to use the other one. So here, your level of significance is 0.10, and you have a lower tailed test. So here is your lower tail test now. It is the blue region, sort of, here in the table, and we're looking for 0.1, which is the first one here. So in line with one-sided lower tail, then 0.1, it's minus 1.28. So this is your critical limit, minus 1.28, which you'll go back to the diagram and write down under your critical limits that it is minus 1.28. As you can see, it is a negative because this is a one-sided lower tailed test. So now that you have that, you need to write it out in words. So you will say, accept the null hypothesis if your test statistic, your Z statistic is, so you'll accept, there's the region here of acceptance. It's where it's greater than or equal to. In fact, again, you don't need to write the whole word Z stat. You can just say if Z is greater than or equal to minus 1.28, and you will reject the null hypothesis if Z is less than minus 1.28. Okay, and that is your step 3 done, sorry, your step 2 done to determine your region of acceptance and rejection. Now, step 3 is to calculate your test statistic. So again, remember, as we had done earlier, I had wrote down the formulas for this. Your Z value is P minus pi over the root of pi multiplied by 1 minus pi over n. Okay, so now we're going to work that out. So P is here, the 0.09 that we calculated, minus your pi value is 0.10. Then it's over the root of pi, again, is the 0.10 multiplied by 1 minus pi over n, which we said was 320. So this then on your calculators is going to be minus 0.6. Oh, sorry, forgot the 0. So it's minus 0.60. And now for step 4, we're going to compare that to your region of acceptance and rejection. So it is a negative value, but it's a smaller negative value, which means it most likely will be somewhere here. So that's minus 0.60, which is in your region of acceptance. So now you're going to say, therefore, accept the null hypothesis. But again, you need to elaborate. So you'll say which indicates that. So if you're accepting the null hypothesis, go back to the null and alternate hypotheses. Your null hypothesis, if you're accepting it, you're saying that it is true. And what it says is that it's actually more than 0.1 or more than 10% of the customers that complain about the company's products. So you can either say that, so you can say which indicates that more than 10% of customers lay a complaint about the company. Or if you want to, you can also say that, remember, the claim was in the alternate hypothesis. Here's the claim here. And if you're accepting the null, then you're basically rejecting the alternate, which means that you are saying that the claim that this company is making is not true, or you can say that it's false. So I'm going to say here, I'm going to put in a slash here and say that what you could also say is that it indicates that the company's claim is false or it's not true. So whichever you prefer. If you want to say the sentence about accept the null hypothesis, which indicates that more than 10% of the customers lay a complaint about the company, you can say that. But if you want to, you can just say accept the null hypothesis, which indicates that the company's claim is not true. All right, and that is it. So that is it for your hypothesis testing. These are the typical type of questions that you can expect. They're all from past papers, as always. So you have an idea of what you can expect in your exam. Again, though, remember this is a section that is optional. So you're either choosing this, which is Learning Unit 8, or you're choosing Learning Unit 9, which is the last learning unit. Any questions from your side? Yes, of course. I know it's quite a bit to take down. There's quite a bit of writing that goes into these questions. Sorry about that. Any other questions from anyone? Pretty good. The assignment marks were pretty good. I have completed marking them, so it's just now a matter of the online center verifying them, and then once they're done, it will be published. Hopefully, maybe by tomorrow or Friday, it should be released. But the results were pretty good. Yes, well done to you all. Okay, so if there are no other questions, then I'm going to end off for today. Thank you, everyone. Enjoy the rest of your evening. I will upload this to YouTube, and I am also going to upload two additional, actually, I think it's one additional recording for this section, this hypothesis testing section. So you can watch that as well, just to reiterate, to just get through a couple more examples of this. And then I have also already uploaded, and I did send out an announcement about that. I also already uploaded an additional revision worksheet for this learning unit. So please, can I ask that you do practice these questions if this is something that you see yourself going ahead with in the exam. Please have a look at those questions and watch the recording, and I will chat to you again soon. Thanks, everyone. Cheers.